Okay, so today is day 2 on trig identities, and we're going over last night's homework. It's pretty rare, but then again, I didn't post the answers, so this is the part where you find out if you were doing it right. So you replaced, I was going through a student here, you replaced that with what? Sine squared. Now, you can't see this at home, but I have a big list of the identities. Actually, I will pause for a second and bring it up on the screen so those at home can have this. Okay, we took a second and did this problem as a quick proof while I went out and got some copies. So anyway, just a quick, here's a normal proof. And you could do this 2 ways. I did it one way when I originally wrote the problem, and then I realized, ooh, there's a smarter way. You can replace sine squared with something, but I think there's a smarter way. If you replace 1 minus cosine squared with something, you'll actually make the problem a little smaller and simpler, right? Then you can replace that with sine squared. And then it's really obvious that sine over sine, this part right here, will equal 1. And then I make that equal to 1, and then 1 over cotangent, so there's a good proof, right? You think I'd accept that work?
No.
Not even close. Okay, you can do one step at a time. So first step I would show is rewriting this and putting sine squared didn't change over that gets changed to sine squared all over cotangent. Then I can show how that cancels that, and now I have 1 over cotangent. And then I can do the final, which is, what is 1 over cotangent? Tangent. And then that equals, and you bring down the other side all the way down, tangent. And now, as long as you end with an identity statement like that, you're good. Raise your hand if you had that correct. Okay, good. That's the basics of what we are up to right now. So, now back to the homework that you did for last night. Okay, let's go over to this one. Do you get cosecant squared minus 1? It's not on the list of identities, but it's easily achieved from it. Here's the one that has cosecant in it. Remember the one with the coat is cozy? Just a dumb way to remember it. Back when I forced you to memorize, back when I forced kids to memorize these things, they're in a regular calc, I believe they have to have these memorized. They give them some of them, but I'm pretty sure they don't give them the Pythagorean or the reciprocal identities. You have to know those by heart. Okay, so I would expect you to know them by heart too. All right, so anyway, cosecant minus 1 is really, you subtract 1 from both sides. And look, cotangent is cosecant minus 1. All right, now I could put in cotangent right here, but it'd be cotangent squared. Then I'll have cotangent over cotangent squared, and we do allow you to skip this step right here of saying cotangent over cotangent cotangent, because that's what cotangent squared is, and then these can cancel nicely. We will let you just go cancel, cancel like that. That is a step saver, and that turns it into just 1 over cotangent. And 1 over cotangent is equal to tangent, so I can stop right there, right? Nope. You get it marked wrong. You got to go one more step and say tangent equals tangent. You have to show your work very thoroughly, yes, more than you ever have, because in a proof, it isn't about the answer. Do you get what I mean by that? I know the answer. The answer is tangent. It's all about you showing how it gets to tangent. So yes. Nope. If you're asking, can I skip any steps? Nope. You have to show me every single step, and I reserve the right to mark it wrong if you don't show me every single step. But there's only going to be like 4 questions on your whole test. You got time. Yes.
Okay, so for this specific problem, can you replace the bottom right away with the cotangent squared, or would you have to write that and then?
No, I did. On my very first step here, I replaced the bottom here with cotangent squared. That was my first step. I can just go right to that. Yep. You don't have to show this little thing where you took a identity and solved it. No, that's just for me showing you how I knew that I could put cotangent there. All right, let's move on. And I know that the next ones this one was pretty easy. If you did it my way, I just want you to show you this kind of interesting way to do it. You factor out the -1. I think that's what I told you to do. Do you get by factoring out the -1, I just made it perfect so that that will equal 1? Right? So then it's just 9 minus 1 times 1. So then it's just 8, and 8 equals 8. That comes down, and yay, we're done. That one's not too tough if you do it that way. But one of the teachers did it a different way. I wonder if any of you did it the way he did it. He said you can replace sine squared with, well, if you look over on the list, this one pops to mind. Right? And what's sine squared equal to? Subtract cosine squared from both sides. And sine squared is equal to 1 minus cosine squared. Right? So he put in 1 minus cosine squared right there. And he had 9 minus cosine squared minus, and we replace this with 1 minus cosine squared. What's cool about that is that after I distribute this all out, your minus cosine squared cancels with your plus cosine squared, and then it's just 9 minus 1, and so it's 8. So that's just 2 ways to do it. The point is, there's a lot of different ways to solve these problems. Don't think that, oh, I couldn't figure out that one step. Well, there's a different way you could probably do it, totally different. Starting with a totally, like, I mean, you could start even on the other side if you wanted to. Like on this one, I was working on the right side and I could not figure it out. So then what do you think I did next? Went to the left side. And on the left side, this is an important thing to notice. Tangent to the third, what the heck? Do you get there is no tangent to the thirds on your sheet? And therefore, you should swap out tangent to the third with tangent squared times a tangent. Do you get that's the same thing as tangent to the third? And I'm just going to bring this cosine back down here. Now, as you're thinking through this, do you get that these two together have the potential to do some canceling? Why? Tangent's really the same as what? Sine over cosine. Now, anybody who already did this right, you probably did it a different way than me. And if you got an answer already, I'm cool with that. But I need you to try this way right now. So if you don't have a good answer for this, here you go. Here's a good start. You're going to work on this together right now with the partner that's sitting next to you. So take it from there and make it equal this when it's all done. And the hint I gave you was these two are going to do some canceling next. Okay, let's take a next step. I'd replace cosine. No. I would replace tangent with what? Sine over cosine. I'd say that is in the the top 10 substitutions that you will ever do is tangent switching to sine over cosine. Happens all the time. Then you got cosine here. And then we still have this tangent over here. And now it's just begging to be canceled. So boop, boop, there we go. If you didn't get that far, take it from there. See if you can finish the deal.
Yeah, it's sine cube over cosine.
No, it means just no, not for that. Because something can't.
Yeah. Yeah.
Hohendorn. Tell me a next step. We have this. Now what? 1 minus cosine squared. And I still have this tangent here. Distribute tangent, okay? This times this times that.
Oh, and that I
And we're close, but we're not done because it doesn't look like this yet. But is it looking close to that?
Yeah,
Kind of.
sine over cosine.
Ah, so you're going to replace what with what?
The tangent,
Gets taken out and you put in instead
cosine.
sine over cosine
You cancel out one
times cosine squared. And yes, some canceling will happen. Finish the deal. I'll pause while you do that. Okay, so let's finish this one off. The cosines cancel, and you got tangent minus sine times cosine. All right, and that is tangent minus sine cosine. Cool. And I need to have thetas in there to make it real. Otherwise, that's imaginary words. Okay, so I want to give you one that is something that you probably could easily do, but I want you to show every single step. 1 minus 1/8 over 1 plus 1/8 comes out to some number or fraction. Answer. Obviously, this equals something. I'd like you to show every single step of using common denominators. Like this needs a common denominator with that, and then canceling properly. Why? Because in a moment, this is going to be 1 minus 1 over tangent and 1 plus 1 over tangent. And if you don't get it with normal numbers, you're not going to get it with trig. Okay, so everybody try this one. It's common denominators is the theme. You will need this to be able to handle the test. Now, also, you know that white sheet that's going to have all of the identities on it? I'm about to hand it out now. And I'm going to ask you to just take one and hand it around, one for each of you. Keep it moving. We won't need that many. So let me take some of these back. That ought to do it. And that sheet, which is displayed on my board, is also going to be in your hands right now. On that sheet, I'm going to have you flip it over, and we're going to write down some of the top strategies for these kinds of problems. Like, when you're stuck, think about these options. What do you think the very first thing is going to be? It's my favorite thing. Come on. If you can factor it, you should. And so far, the ones we've done today didn't even need factoring, except the very, very first one, I think. Actually, of your homework, you needed factoring twice. Tonight's homework, you're going to need two strategies, one of which, common denominators. All right, I'm pausing while you show every step of getting this down to an answer like 6/9 or whatever it is. So I'm going to pause while you finish. Okay, it was good for you to have a chance to struggle with that a little bit, but here is how you should be doing them. All right, so this 1 can turn into 8 over 8. And then I have 8 over 8 here. And then I will have 8 minus the 1 over 8 is 7 over 8. And on the bottom, I have 8 plus the 1 is 9 over 8. And then I have to show all of these steps. Now I'm going to show flip and multiply. 7 over 8 times, again, the bottom has to be flipped, 8 over 9. And now the 8s will cancel. Final answer, 7 over 9. Raise your hand if you had that one right. Okay, good. Now, I know some people are going to want to save a step by like doing this. There's no such math property that says you can do that. But there is this step of writing it as flip and multiply. All right? So even in regular pre-calc, we don't allow anything like that. but we do allow you to rewrite it as a flip and multiply and then cancel them. Okay, so here's one that's like that. I want you to prove that 1 plus 2/3, everybody write this one down, 1 plus 2/3 over 1 minus 2/3 is actually equal to 5. Show every step. You have 1 minute. You can do this in 1 minute. You really can. Okay, so did you get 3 over 3 and 3 over 3, which then turns into 5 over 3 over 3 minus 2 is 1 over 3, and then you should flip and multiply. 5 over 3 times 3 over 1, cancel, cancel, and 5 equals, bring it all the way down, 5. Raise your hand if you had that one right. Good. Now, use the same skills that you just practiced to prove this, which is a lot like one of the ones in tonight's homework. It involves the same exact thing. Everybody write this one out. 1 plus cotangent theta over 1 minus cotangent theta will equal tangent theta plus 1 over tangent theta minus 1. Now, how is that at all like what we just did? Well, who can tell me where I can make one substitution and make it look just like the problem we just did? Yes, sir.
1 over tangent.
So I pull out what?
So pull out both cotangent.
One thing at a time. Pull out cotangent,
And then 1 over cotangent.
and you put in
And 1 over tangent.
1 over tangent. And now it's a number, or it's 1 plus a fraction, just like it was before. And now you need a common denominator, just like before. And yes, you do the same thing down here. All right, go ahead and do that and show every single step, because that's what proofs are about. I know the answer. The answer is tangent plus 1 over tangent minus 1. All right, I'm going to pause while you give that one a try. Okay, one step in. You should be at tangent theta over tangent theta plus 1 over tangent theta all over tangent theta over tangent theta minus 1 over tangent theta. And then I hope you notice that you have common denominators, and so they can be added. And then you'll have a fraction over a fraction. And then you can flip and multiply. I'm going to pause for a second while you finish this. So tell me what's next. All right, so on the top here you'd have, I agree, tangent theta plus 1 over tangent theta. And on the bottom, tangent theta minus 1 over tangent theta. Very nice. Now, I can flip and multiply. Tangent theta plus 1 over tangent theta. And instead of dividing, I'm going to say times by. I'm going to flip this thing upside down and put tangent on top over tangent minus 1. And then that cancels that, and I'm down to exactly what I wanted. Tangent theta plus 1 over tangent theta minus 1. There. That was using common denominators. Now, I'm going to give you, take this white sheet that I just handed out to you. I want you to flip it over, and I want you to write, if you can factor it, you should on the top, because that's my #1 strategy for all of pre-calc. If you were stuck, I would try that first, because so often that's the answer. If you can factor it, you should. Next on the list of options when you're stuck, find common denominators. I'm telling you, on the hardest problems, it usually comes down to finding a common denominator. You know, one of the other clues that it's a denominator question? If the problem has a fraction on one side and 2 fractions on the other side. Obviously, if you have 2 fractions, to combine them, you will need a common denominator, right? So if you have one side of the proof has a simple fraction, and the other side has 2 fractions being added, Probably a common denominator question. All right, here's the next major strategy after common denominators. Creatively replace 1. The third strategy I will give you is creatively replace 1. 1 seems so innocuous. It's just like a nice simple number. Why would you ever want to replace it with something more complicated? Well, what if it was 1 over cosine, let's see, where there's some that go together. Secant squared minus tangent squared. Well, as I look at the list of things that have a 1 in it, I see 3 of them. Sine squared plus cosine squared equals 1. Do you agree that replacing this 1 with sine squared plus cosine squared would be possible? They're the same thing, right? I could take out the 1 and put in sine squared plus cosine squared, but that doesn't mesh really well with the secant and tangent that I already have. So do you see where I'm going with this? There's another 1 up there that would work better. The one that's buried with secant and tangent. So let's write that one down. The 1 with the tangent is what you seek. How could that be solved for 1? You can rewrite it by putting this tangent to the other side, and it'll be 1 equals secant squared minus tangent squared. Do you get, if I put this in for my 1, this problem becomes laughably easy? Okay. So on tonight's homework, which that's the alarm, we should be getting to the homework. That's your number 1 strategy, is to find the 1 and don't, I know it seems counterintuitive, but pull out the nice simple 1 and put in something that's equal to 1. You can solve for 1. This one's already solved for 1. But here we had to solve for the 1 by getting rid of the other stuff. There's only 1 left. Cotangent squared theta plus 1 equals cosecant. The 1 with the code is cozy. Remember me saying that? Okay, well what is 1 all by itself then? How do we get this solved for 1? What do you do? You subtract what? You subtract cotangent from both sides. And then I'd have cosecant minus cotangent. All right, so there's 3 things you could do when you see a 1. Sometimes the answer is take the 1 out, put in stuff that's equal to 1, depending on the problem. All right, so now let's look at the homework together. By find day 2 right here. The first one is nice and easy. You just have to do a little swapping, pull out this, put in that. Stuff will cancel. Obviously, this side looks more complicated, so start on the left side. Over here, does this look a lot like what we just did in class a minute ago? Finding what's common denominators. It's just that these are reversed is all. So you make that into, what's cosine the same as? 1 over secant. Does it seem like secant would be a good idea considering the answer has secants in it? All right. All right, so common denominators. How about this next page? What's the hint that's, because the answer is covered up, you can't see for sure, but what do you think they did there? They replaced the 1 with something, didn't they? So strategically replace the 1 with something. And on number 24, I will tell you, even though you might be tempted, I don't think you can strategically replace the 1 with something on that one and make it work. But you never know until you try. But here, I'll tell you the first step, because we are giving hints on these first steps anyways. First step, they replaced, now this is only one way to do it, but it will work. They replaced cosecant with 1 over sine. Would you agree that they're just flipping sisters, so you can do that? Okay, and they replaced regular cosecant with 1 over sine. The cosecant squared was 1 over sine squared, of course. Basically, these are both just flipping sisters replacements. And then cotangent is cosine over sine. Why do you think they used that? Probably because now we can end up with a sign squared down here. And do you see common denominators is kind of built into this one too? Those fractions will be able to be added. Now, how could you have known in the big picture that you were probably going to have to find common denominators? Because look at the original problem. If you look at the original problem here, do you get, I have some stuff that's added together and it equals a single fraction? Do you get to make that happen? You will have to find common denominators. To get this side to be a fraction, there's two separate things. They got to get added together and have a denominator. So that's why you could have known common denominators were going to be involved. All right, so again, I'm showing you that first step was, I erased it by accident. Okay, hopefully you have a decent memory or a copy from the kid next to you. All right, and that's the only 4 questions you have for tonight's homework. So, on your list of strategies, so far, we have if you can factor, you should, find common denominators, and creatively replace one, as in one can be replaced with lots of different things. I want to give you a bunch more things, just one at a time, as we come to them. And tomorrow I will teach you more about the other identities, the odd evens and the cofunctions. That's on the docket for tomorrow. So if you're like, I don't even understand half the ones on the sheet. I understand. I get that you don't know them yet. All right. Last thing I'd like to do with you is give you a little bit of work time to work. Tempting for me to throw in one more problem, but I think you need some work time in class. So don't abuse that by just saying, oh, I'm going to quit now. I'm leaving you 8 minutes. You got a partner. You got homework. Get one done with your partner. Maybe even 2 if you're lucky. Okay, that's all I got for you for now.